Alright, so I will be covering the last collection type, which is sets. And basically sets, they store distinct values of the same type with no defined ordering. So it's basically a data structure. So remember, when using a set, if you need to use a set and you realize, okay, the data that I have, that I really don't care about the order and I really don't care if it has indexing or if it doesn't have keys, then sets are the way to go. So I'll be covering how to create and initialize an empty set, creating a set with array literals, also a little bit on how to set a set with type inference, how to modify and access an array through its methods and properties, iterating over a set with using for-in, which is pretty standard whenever you're dealing with sets to use for-in. And then something a little bit different with sets is that sets actually do have operations. And so I'll briefly cover the 4 operations in which you can perform with sets, which is intersect, exclusive OR, union, and subtract. And then a little bit about set, membership, and equality. So go ahead and get started. So how do you create a set? This is kind of how a set looks. You have you define a variable with set, and then you define what its type is, what the element type will be. All right, so let's go ahead and create one. So we'll go ahead and do var, because we want our set to be mutable. Again, like I mentioned, you can make it immutable, but once you make it immutable, you can't do anything like modifying it or deleting any values in the set at all. So I'm going to make it mutable with var. I'm going to call this letters. So I'm going to put particular letters inside this set. And then with this notation here, I'm going to do set, and then our little caret keys. So char, we're going to do character. And then we're going to do parentheses. And so when we create the set, using the parentheses will actually initialize it. I believe when you don't do the parentheses, it won't. Yeah, it errors out. So we need to make sure that we have the parentheses with sets, especially if we're creating a brand new one with no values in it at all. Okay, so let's go ahead and add something to the set. So the way you do that is you do dot notation. So we do dot insert, and then we enter in what the value is. So I'm going to do value A. And you see here the set contains A. Now I'm going to create another set. This time I'm going to do, let's say, music genres. So music genre equals set. And I'm going to create a string, because these are going to be strings. And then the caret key, parentheses. And then I will, actually, I'm not going to do parentheses. I'm actually going to create this set. So instead of doing that, I'm actually going to create it with an array literal. So I'm going to jump down here, copy this, which actually brings me where I need to be. So an array literal, and then I will enter in the values like I would do an array. But the thing is like I said, with arrays, it creates an index for each value. In sets, there are no indexes and there are no keys. So I have to make sure that 1, the values are hashable, and 2, that they are in the types that Swift allows, which is string, int, boolean, and double. So I am creating music genre with strings, so I'm okay. So I'm gonna create music genres. I'm gonna say rock. Let's do pop. Dance. Rap. I guess I'll do more classical. I'm sure there's a lot more genres than that, but that's all I'm gonna do. So here our set shows that we do have 5 different values in our genre, and if you notice, they're all the same. Now I'll go ahead and show you if we add something to music genre that already exists, doing an insert. Let's say I put in rock again, I should get an error. Well, I don't get an error, but it already exists, so it's not going to duplicate it. So again, all these have to be unique. So let's say instead of doing rock, since we already know that rock exists in the set, let's do something else, like dubstep. Why not? And you see it pops in dubstep. And you notice it didn't pop it in at the beginning or the end, it just popped it in wherever. Alright, so that's how you set it up with a literal. And you know, we can also set up a set using type inference. So if I have, say for example, var art styles, it's a good one. If we equal this to, sorry, we create a set, but we don't define what its value or what its type is, it will infer that type from the values in which we enter it in. So I'm going to do art nouveau data, and let's see, futurism, and my absolute favorite, Art Deco. Okay, so you see here it created a set, which is awesome. And if you hit Option, hovering over the variable, and then click it, it will tell you that it's a set of type string. And that's exactly what it is. So you can also, again, set up, you can create a set with type inference. And again, make sure that it's all the same type and they're all unique. Okay, so let's go ahead and play around with some of sets, methods, and properties. So let's do count. You know, like we did with an array and with dictionary, same deal. So we'll call a set. Let's do music genre dot notation count, and it should count how many values are in that set. In this case, it's 6, and that's correct. Is empty is another one. So we know music genre isn't empty, but we can determine if it is or not. In this case, it's not, so it returns false. I did use insert here above with dubstep and with a. Same deal. Let's go ahead and add another art style. So art style, oopsie, don't use var, just type in art style, dot insert, and then you enter the member. Again, it has to be hashable. So let's do Baroque. Right, and it should pop it in there. And it does. You notice it just popped it in wherever. This is not ordered in any way. It just pops it in. Alright, and then remove. Again, removes a value from that set. So let's do music genre again. Actually, let's do letters. I want to move that A. So I'm going to do letters, remove, and we'll do A. And what it should do is it should remove A So when we call letters, it should be empty. And it is. So that set is absolutely empty. Letters has no values at all. Let's see, let's create another, because I really don't want to remove everything. Well, let's just remove everything from art styles, why not? So let's do art styles, remove all, exactly what it means, it removes everything from that set. So when we call art styles again, it contains nothing in its set, as you see here. And then we could do contains, so we can search for a value in the set. So since we only have music genre, we do contains, and we can ask it, do you contain folk music? This is false, no. And we haven't added it, right? But if we do something that we know it contains, like pop, then we'll say yes, or true, which is correct. Alright, so iterating over a set. So, you know, it's great that we have a set, but we want to see everything that's in it. You use for in, just like we did with dictionaries, like we did with arrays. Same deal, we use for in. Okay, so do for, and then we say style of music in music genre. And then we do print, we print out the music genres. So we do style, and it should output down here. Oops, see? Okay, forgot my quotes. That's not very happy with me. So now it should output all the styles here, and it does. So dubstep, rock, dance, etc. Now say if you wanted to output this but have it in alphabetical order, you can again do sort, so dot sort, and it should sort, oh no, it does not sort. String has no sort. So actually I think we can do sort here. Nope. We can do sort on music genre, pretty sure. It does, okay. Yeah, so you get those wonderful error messages. So yeah, you can do sort, again, if you add the parentheses in order to do so. And it sorts classical, dance, dubstep. Because if you noticed before, it didn't really sort at all, just okay, whatever. Alright, so that brings me to fundamental set operations. So these are operations that you can perform on sets. The best way to describe this is just to jump in and show you. So I'm going to create a couple of sets. I'm going to create one that has odd, even, and prime numbers. So 3 different sets. So let's go ahead and get started. Now again, I'm doing let, or a constant, on a set because I'm not going to be doing any modification to this set. So again, you can do, or you can make a set a constant. The thing is you have to know that you're not going to be able to do any work on it. So once you set it, it's set. You can't modify anything unless you go into the code and modify it. Alright, so let's do let odd digits. So we'll create some odd numbers. Actually, I'm just going to do odd numbers, just make more sense to do that. And then do set. I'm going to use type inference. So I'm just going to create my little array of numbers. So odd numbers begin at 1, oops, 3, 5, 7, 9. So I'm only going to do up to 9, so 1 through 9. Then let even numbers. Again, this is a set. So our square brackets. Even numbers 2, 4, 6, 8. And then I'm going to do my prime numbers. Set. and square bracket. And our prime numbers are 2, 3, 5, and 7. Okay. So intersect, A intersects B. So what this means is we're asking it, does the sets have numbers that overlap? Okay, so let's do odd digits, or odd numbers I should say. Intersect, so do the odd numbers intersect prime numbers? And this actually should be true. Did I spell that wrong? Oh, I did intersect, insert instead of intersect. Okay. So let's do prime numbers. Okay, so it should, so it outputs the numbers that are similar between the odd and the prime numbers. And another thing we can do is we can actually do a sort on this so it's easier to read. So we do dot notation again, sort, and it will order it for us. So we see here that the order is 3, 5, and 7, which if we look at what we input, it's true. 3, 5, and 7 are the same in the set for the prime numbers. Okay, exclusive OR looks at those that are not contained, I believe, in either in the set. So we do odd numbers, exclusive OR, and we do prime numbers, and we'll do a sort on this as well. And we'll see the numbers that are not included. So it's the complete opposite here. So these are the numbers that are not the same between the two sets. So for the odd numbers, 1 is not in the prime numbers. 2 is also not part of the odd numbers. And 9 is not part of the prime numbers. So you see that it looks at all the values that are not contained in either one. Okay, so union, let's see what happens when we do something with union. Do union, odd numbers, even numbers, and we'll do a sort on this so we can see what it looks like. Alright, so this includes all the numbers 1, 2, 3, etc. all the way to 9. So this combines both sets into one. So, I mean, well, not into one unless, if I create a variable here and say var all numbers equals this, then all numbers will contain all the numbers. As you can see, so all numbers now becomes a set. So that's union. Now subtract sounds like what it does. It subtracts those numbers that are, I believe, the same. So let's see if I'm correct. So even numbers subtract prime numbers. We'll just do a sort. And if we look at our even numbers, see 2, 4, 6, 8, we see that 2 has been subtracted because 2 is part of the prime numbers. Alright, let's see what happens when we do odd numbers. Prime numbers, sort, and we see it, there's 1 and 9, because if we look at the odd numbers, has 1 and 9, which is not included in the prime numbers 3, 7, 5. So I subtracted 3, 7, 5 from the odd numbers. Okay, so that is fundamental set operations. So set number and equality. So I kind of added this little blurb here just because it just makes it easier for me, but hopefully makes it easier for you to understand. set membership and equality. So basically we're going to have three sets, A, B, and C. And as we go through these, we'll see or kind of experiment with how they behave. Okay? So I'm actually going to create some new sets here to experiment with. So I'm going to do I'm going to do sum digits. I'm going to set this equal to the even digits or even numbers. Actually, I'm going to create that. Instead of doing sum digits, I'm going to do some numbers. Okay, and then I'm going to create another set. This time I'm going to create, I'm going to say I call it a tiny set of numbers. Because it's only going to have, you know, just a small amount of numbers, not a lot. And there's no rhyme or reason to this. I'm just creating a set. Okay. All right. So the double equal sign means equality, and I've covered this before. This is really similar to logical operators where you have the double equal sign. Does it mean equal? It's to determine if something equals something else. It's not assignment like I did up here. This is assignment. This is not assignment down here, not at all. All right, so what we're going to do is we're going to say, okay, does even numbers equal sum numbers? And we know it does because I created the variable up here. Oopsie, again, not assignment, but equality. So you see that wonderful error message, and it's true. It does equal the same. All right? Is subset of. So basically this is asking, does one set contain the values of another? It might contain all of them, it might not. So let's look at some. Actually, is subset means that it contains, it contains all of them. So let's do sum numbers dot is subset of even digits or even numbers. And that's true because sum numbers equals even numbers. All right. So is superset of is asking, is one set contain or has some or all of another set? I don't know if that makes sense. Well, let's play around with it. So if I do even numbers dot is superset of some numbers, should be true. Well, let's see if tiny set is, or if even numbers is also a superset of tiny numbers, since it does contain some of the numbers. And that's true. So if you see here, a tiny set of numbers has 2 and 4. And if we look at even numbers, it does contain 2 and 4. But even numbers also contain 6 and 8. But because even numbers is a superset, it is true. And the same thing with sum numbers, which equals even numbers to exactly. It is also a superset, but you can also say the same thing of some numbers as well. So if we do sum numbers is superset of even numbers, it will also be true too. Yeah, it's also true. Alright, so same deal with subset of as well. Okay. Is strict subset or is strict superset of? Kind of the same deal, but it's strict. So if we do tiny set of numbers is a strict subset of even numbers, it should be true, which is right. Can we see the same thing of some numbers? Let's see. So some numbers is strict subset of even numbers. Yep, it's false, because strict subset doesn't necessarily mean that the set has to equal the superset, it just has to contain. So it's more, it doesn't look at if it's equal to. But say if some numbers is missing a number, like say instead of having 2, 4, 6, 8, it has, let's remove 1. So let's go up here and figure out how to remove 1. So we remove, let's have some fun. We'll do some numbers, remove, and we're going to remove, let's say 2. And let's see if some numbers now is a strict subset of even numbers. And it's true. So as you see, it's not necessarily that with strict subsets, it doesn't look at equality, it looks to see if it contains. So if it has everything the same exact number of values in its set, then it's going to be false. Whereas is subset of does look at that. As we see, if some numbers is a subset of even numbers, even though even numbers and some numbers equal the same. Strict subset is, again, strict. It doesn't look for equality. It looks to see if it actually contains those sets of values. So next, let's go to disjoint. Disjoint just means, well, let's see what it means. Okay, so let's do even numbers is disjoint with odd numbers. Let's see what happens. And that's true. So let's take a look at even numbers and odd numbers. So even numbers does not contain anything within the odd numbers set, which makes sense. So it would be disjointed. So basically it doesn't contain any values at all. Let's see if this also is the same with the prime numbers. Let's see if it's disjointed from the odd numbers. And that's false, which is true. That's actually accurate. Not true, but accurate. Because prime numbers do contain some values that the odd numbers contain. So it would be, the disjoint would not be true. Alright, so we've covered quite a bit. We've created sets. We created a set with array literals here. We have learned how to access and modify sets through its methods and properties. We iterated over a set. And then we had some fun with fundamental set operations and membership and set equality. All right, that's it for collection types.